All right, everybody, welcome to another pre-recorded lesson here on YouTube. This is Mr. Campbell here. We are continuing today on our moon science, our lunar science, as we finish up this second half of the unit. And that, again, don't forget, we have a writing assignment due, and we'll have some notebook checks and online tests next week. Number one, what exactly causes tides? This is on page 8 or 9B of your notebooks. 2, which influences tides more, the sun or the moon? Explain. And 3, what would happen if Earth lost its moon? Interesting stuff there. Number 1, what causes tides? It'd be the moon and sun's gravity. Moon and sun's gravity. But which of those two is going to have a greater influence? It's going to be the moon for number 2 because it is closer. Moon because it is closer. And if the moon disappears, what would happen? I've actually got a quick video I'm going to show you guys for that. Let's go ahead and check it out. If the moon disappeared, what would happen? I don't think I showed this in the last video, but let's just go ahead and check it out. Let's see what we have here.
Our moon is on the move. Each year it drifts an estimated 1.5 inches further away from Earth. And in the process, Earth's rotation is actually slowing down. What if one night the moon simply disappeared? Would we miss it? A full moon is on average 14,000 times brighter than the next brightest night sky object, Venus. So without it, every night would be as dark as a new moon, and stargazing would be spectacular. But by the next morning, you'd begin to realize just how important the moon is for life on Earth. To start, between the sun, Earth's rotation, and the moon has the largest influence on Earth's tides. Without it, high and low tides would shrink by an estimated 75%. This would jeopardize the lives of many types of crabs, mussels, and sea snails that live in tidal zones, and disrupt the diets of larger animals who rely on them for food, threatening entire coastal ecosystems in the process. Within a few decades, we would start to see mass population declines in the sea and on land. One of the largest spawning events in the world occurs in the Great Barrier Reef. Each November, in the days following the light of a full moon, coral colonies across the reef, spanning an area larger than the state of New Mexico, release millions of egg and sperm sacs within nearly minutes of one another. Scientists are certain that the full moon plays a role in the timing, but exactly how remains a mystery. On land, animals like these red crabs also use lunar cues to reproduce. After living most of their lives on the mountains, millions of adult crabs migrate down to shore. And then, only during the last quarter of the moon, females release their eggs into the sea. Now, the moon may not hold as much sway over human reproduction, but without it, something we care equally about would change: the weather. Tides and tidal currents help mix cold Arctic waters with warmer waters in the tropics. This balances temperatures and stabilizes the climate worldwide. Without the moon, weather forecasts would be practically impossible. The average difference between the hottest and coldest places on Earth could grow to life-threatening extremes. But none of this compares to the biggest change that we would have coming over the next millennia. Right now, Earth tilts on an axis at 23.5 degrees, mostly due to Moon's gravity. If the moon disappeared, Earth's axis would wobble between anywhere from 10 to 45 degrees. Some experts estimate that Jupiter could help keep Earth's tilt from reeling completely out of control. But even just an extra 10-degree tilt could wreak havoc on the climate and seasons. In the past, Earth's tilt has changed by about 1 to 2 degrees, which scientists think could have caused ice ages in the past. It's hard to know what a 10-degree or 45-degree tilt would do, but probably nothing good for most life on Earth. The moon isn't just imperative for life on Earth today. Experts believe that it might have also played a key role in the formation of life more than 3.5 billion years ago. Turns out, the moon isn't just a beacon of light in the night sky. Its existence is crucial to the delicate balancing act that makes life here possible.
All right. So again, the moon playing a vital role for everyday life, for a lot of things on Earth. So what did that video mention there? It mentioned first and foremost, we've got improved view of the stars, but also some negatives here. We have loss of marine ecosystems, and we saw those mountain crabs. A lot of shoreline creatures will be diminished because the tides will be less pronounced, they'll be much weaker. So without that moon, the water will be much more calm, which will also affect our weather. That means waters get transported and move around less across the globe. So I'd say overall, not a good thing. It'd be a bad thing. Less diversity, less variety in our ecosystems and on our planet. So those would be the major impacts that the moon's loss would make on our planet, guys. We just saw that. Add page 10, moon phases, page 10, moon phases. Again, I've got just 7 minutes here left. So I'm going to kind of speed through some stuff here. Ignore that. Ignore that. We'll get to that later today. Let's go back. Again, as I showed you the other day, we had to set up the moon phases sheet, right? So we have here, no, not moon phases, spring and neap tide, right? So sun and moon there, spring tide there, and neap tide there, right? So all the, as we can see, right, all the moon stuff. Again, the last video, the previous video, you could have paused and get all these down easily. So I think we did solar and lunar tide. We need to do these last two together. So let's go ahead and do that real quick. All right. So just in case you didn't see it already, I mentioned like what are tides. Again, tides are the periodic rise and fall of sea levels. High tide is the highest level. Low tide is the lowest level, right? And then again, we're not going to worry about this because I'm doing it for the class in person. But lunar tides, again, the moon has the largest effect since it is closer to the Earth. We've already discussed that, right? So moon has the largest effect, but also the sun has effect. So the sun has a smaller effect despite its large size since it is so far from Earth. But again, it's massive, but it's far from Earth, right? So that's the deal with that. So lunar tides, moon has the greatest effect. Just know the sun has a lesser effect, but it does still have an effect because of its large size. Now, the types of tides we get all depend on the alignment of the sun and the moon together, right? So we watch that. No worries. We're all good on that. What if there was no moon? So spring tides, just keep in mind, again, pause the video as you see fit. We need to write all of this in the columns we drew out on page 9. Okay, so yeah, during full and new moons, we already drew this, right? So the full moon behind the Earth, new moon in front of the Earth, blocking the sun. When the sun and moon Earth form a straight line, again, making those strong tides because they're pulling across the same plane. That gives us our super high tides and our lower low tides, right? So those are spring tides. Hence the word spring, springing up and down, right? Okay. And then moving on to our last category of today, we got neap tides. So the opposite. If you know the spring tide, neap tide is just the opposite. It's instead of it being full and new moons, we get first and third quarter moons, kind of like those half moons, right? Half full, half new. Sun and moon Earth form a right angle, 90-degree angle, guys, right? We see here the first quarter moon, third quarter moon, right? Forming the letter L, and then tides are diminished, meaning they're lower high tides and higher low tides. Okay, so more happy medium tides. So spring tides up and down, higher high tides, lower low tides. Neap tides more in the medium. It's lower high tides, higher low tides. Happy mediums. Okay. Let's go ahead and do our last question of the day. That pretty much concludes everything today, guys, so far. Let's do a quick question. Haven't gotten one yet today. All right. Which scientific law discusses force, mass, and acceleration? And I'm not speaking about the force used in Star Wars there with Yoda. Is it A, Kepler's second law, B, Kepler's third law, C, Newton's second law, or D, Newton's third law? See what you think. Pause the video. See what your answer is. Okay. Answer is going to be letter C, Newton's second law. Force equals mass times acceleration. Stay up to date with your lessons, guys. notebook check next week, online test next week. So be on the lookout. A lot of grades points will be given out next week. This is Mr. Campbell signing out.